Hello, and welcome to this XP Live webinar. My name is Catherine Tran, and I'm a part of the marketing department here in the XP Solutions Portland office. So today's webinar, we will review the data sources such as GIS data, CAD, rainfall, and design information that modelers use to build the flooding context. For those of you who may not be familiar with XP Solutions, we have a long history of providing high-performing software solutions. So our intention is to make sure that in your work you can model with confidence. This means that we strive to provide excellent customer service and support, and that we offer continuing education opportunities like these for engineers in our industry. Today's presenter is Matt Anderson, our Storm and Flood Products Manager. Matt joined XP in December of 2016 and comes with very valuable experience, especially for today's webinar, as he spent 6 years with Autodesk, most recently as a product manager. He's also spent over 16 years as a private engineering consultant, and over the past decade he's been involved in improving the workflows and the technology that engineers use to study and design civil infrastructure and water resources. So thank you all for joining us today, and welcome, Matt.
So welcome to today's webinar, Data Preparation for Flood Modeling. But before I get into more of the meat of my presentation, I have a couple of questions that we would like to kind of ask you. Can you launch the first poll? All right, so you should be seeing a poll. And if you guys can go ahead and begin voting, I want to ask what are the problems that you find yourself trying to address? What are the typical flood problems? Are you dealing with FEMA and ultimately resolving to NFIP flood maps? Are you dealing with regulatory or operational models? Operating a dam or a canal system? Are you investigating a big storm, an event that occurred? Do you find yourself planning for emergencies or mitigation for flood damages? Or analyzing design project impacts as that last one? I find myself, that's primarily my biggest time that I've been doing flood modeling is doing that. So we'll go ahead and let the votes kind of stabilize here, and we can go ahead and present those, show those to users. So we've got there's a about almost 70%, some kind of design impact, some kind of big event, but that's informative on the other elements. So all right, thank you. The next question, if we can launch the next poll, is what are your challenges with respect to your data? Are you a GIS wonder and you have no problems bringing everything into XP? Or you find yourself that you always have problems. You're having to limit the scope of all of your data, or occasionally you need to focus some of that data. Maybe the imagery is too large, or the topography is too large for what you're modeling. Or hey, you don't have any problem with data. You create everything from scratch. You're a data entry guru, or you're really unsure as to where to find some of that data. Go ahead and lock that in and go ahead and show them those results. So a good 43% of you unsure really where to find a lot of data, which we'll cover a little of that a little bit later. Focus some, too much data is typically, but 9% of you guys are scratch models. Congratulations, pretty good. Wow, zero, no problems. Good, so it's good, good that we're doing this webinar. So let me go ahead and take a look at, the meat of the data. So thank you for voting and participating in that. So as we look at how do we prepare data for flood modeling, we want to keep in mind that, as modelers or as engineers, we're trying to stitch together a kind of a comprehensive story of what happens, when it floods. We occasionally, look at that floodplain out of kind of that lens that we're comfortable with, that modeling lens, if you will. However, in many cases, our task is really to communicate what that risk is, or that impact of that flood on someone or something. We typically have to present that to an agency. Maybe it's FEMA, maybe it's a flood district or a stormwater district, maybe a city or a county, where we have to provide that model, maybe through XP Viewer, where we encrypt the model and send that to the regulatory agency so they can poke and prod and ask questions as an agency. Or maybe we just need to convince, users or the local agency body as to what our findings are. And to accomplish this, we want to be pretty efficient in how we set up our model, so we can, ultimately provide some versatile results that help communicate what that story or that impact of that flood will be. So in the next just shy of an hour, 50 minutes roughly, we're going to talk about the data. How do we prepare it in flood modeling? How do we go about doing this? What data do we need? Where do we kind of massage or focus that information? So let me just kind of walk you through kind of the story of how I look at data preparation. The initial one really is contextual data, that spatial data. We're living in a three-dimensional world. We're trying to communicate and with two-dimensional elements, to try to look at how that aspect of flooding occurs. We can do that with topographic information. We can do that with aerial photography or imagery. All of this helps us to begin to construct the model, whether we're just dealing with a two-dimensional model or whether we're dealing with a mixed model where we have two-dimensional flood elements as well as one-dimensional elements that may require some terrain information. So having that terrain information in our flood model here in XPSTORM is helpful. It helps us provide that story. That aerial photography, whether that's satellite or locally flown data, helps us provide, that visual nature, that visual spatial context of a project. Makes it a lot easier for us to understand and, project that information to whoever we're going down to. From a background, I came from HEC2 in card format before we had some somewhat visual nature of cards, and it was always interesting when I got old historical models, whether they're WSP2 or Lyell or HEC2. I always had trouble spatially trying to figure out where that cross section was because the data there wasn't available. So that contextual spatial data helps clear up what that flood model was intended to display. As a lot of you, I think it was 60, almost 70% indicated, you do a lot of stuff with designs, existing flooding, what happens after we put the bridge in, or what happens when we put the pond in, things like that. So how do we utilize design data within XPSTORM? And that can come from MicroStation, that can come from the AutoCAD platform. How do we leverage CAD data or design data in XP? Similarly, and I'm not going to cover much of it, but the similar process as GIS data. GIS, probably more of our historical assets. I'm not going to cover a lot of that here, but more on the design functions. But the similar workflow or similar process will apply. And kind of lastly, we have simulation data. We have some of those free government-sponsored tools, HackRise, EPA SWIM, that occasionally will offer that SLIM functionality to help us define flood modeling, but usually leaves something else out. For example, HackRise, if we have sufficient pipe information or we're trying to do an urban flood modeling with buildings and things like that, not exactly helpful if we have a lot of storm sewer. Okay, so how do we leverage maybe an existing conditions model from HackRise within XPSTORM? So we'll talk a little bit about that, and I'll demonstrate that a little bit later. But we also want to look at, how you can leverage other XPSTORM or XPSWIM data. We don't want to, these are not isolated islands, if you will, of simulation data. We want to be able to utilize and reuse that information in designing the next stuff or the next model. So we can actually reuse model information, say, within our global database to repeat work down the road, and that's pretty helpful. So a lot of you, I think it was a 43% identified that you sometimes have trouble finding data. It's not sometimes readily apparent. And I kind of just walk you through my favorite location, the U.S. Geological Survey. I'm sure there is a Canadian equivalent. Unfortunately, I'm not 100%. I haven't done any Canadian work, so I've visited. But Earth Explorer at the usgs.gov is a great resource. It requires a login, but it does provide both graphically with a map as well, for your project area. If there is LiDAR or Aster DEM or other DEM type data, as well as aerial imagery information, pretty well up to date, available for download. I think, if I recall correctly, and I've yet to purchase anything from USGS, they do have and offer some paid data. But just check when you're there. Make sure that the licensing and attribution requirements that go along with some of the data, in your paid work, that you follow that. But that's typically where I grab a lot of my information. If I don't already have that, and I usually will always have it if I've checked with my local agency. I was in Illinois for a number of years in that private practice and relied heavily on the local county GIS department for a lot of their GIS data, their photo data, as well as any LiDAR data, which was extremely helpful, much more in the later years, because a lot of the stuff back when I started practicing as an engineer, the internet really wasn't around too much. So, but it's helpful to get some of that. But one of the other problems that, in many cases, and I think everybody pretty much said that they usually have some kind of trouble, is being able to limit or focus that data for their flood model. We typically don't want to be modeling adjacent watersheds. We want to focus our work on one location. And while USGS will give you a plethora of GIS data, sometimes we need to focus that. We also need to look at the metadata, so the information about that. For example, a lot of data is in GeoTIFF format in a metric UTM coordinate system. Coming from the US, I use the Imperial for all my design projects. So XPSTORM is unable to perform those coordinate transformations on the fly between UTM and the state plane coordinate systems. So we want to translate and focus that data with some tools. And OSGeo, OSGeo.com, I think, or org, provides what's called the GDAL, or Geographic Library, and a lot of software applications utilize that to, reproject and translate GIS information. And that is the library I use primarily through QGIS. QGIS is a free open source tool. It will help you translate and focus this data so you can use it. It's pretty easy. The GDAL library is a lot of command line driven stuff, and I'm a very graphic person, so I find QGIS to be the tool that I use to manipulate and translate and focus all of this data. Again, transforming and focusing it. So let's talk about the spatial context. The first one, aerial imagery, aerial photography. This is providing that visual background of hopefully our site location, and it helps us, capture what's going on, visually. It helps us to be able to identify different land use polygons, whether that is grass and shrub or whether it's farm field or concrete. If land use polygons in our area aren't available, the aerial photography helps us provide that visual nature to help us digitize that and store that. Now, I know that there has been a lot of advances in methods that firms are using to capture reality. Those may evolve, but the goal ultimately is to capture that state of reality, both not only in the mesh, the surface, or with the imagery. And XP wants to be able to utilize both of those. So the other one beyond imagery is going to be building a terrain model. Okay, and XPSTORM, XPSWIM as well, both have that ability to build a digital terrain model based on some information that you can provide. Most of that is in a format, an XYZ format, northing, easting, or easting, northing, and elevation. In a, typically in a text format. It can come in an Esri grid file, which is an ASC text file. Again, it's just XYZ, or its binary equivalent, which is the FLT file. We also consume a file format called 12D. It's an ASCII file format, supposedly human readable if you know how to decode it. But it is the export from 12D, which is an Australian company, and it's much more common in Australia. But I've seen it here in the U.S. I've seen it in other places around the world. But we can actually import that 12D archive. We can pull that surface into our model, and we can utilize and we can have more than one surface in our system. But it's only that top surface within that list that gets leveraged for building our two-dimensional flood surface or being used to populate our nodes and our links in that site. But one of the other elements that we typically do not, it's really not that apparent. And talking with the developers, we may want to look at how we make this a little bit more apparent, is land XML. Okay, land XML, if you import the land XML from the file import, the file menu, pull it down to the import, select land XML, you can import a land XML surface. So really 4 different ways of getting that surface in. Okay, so let's go ahead and let me switch over to XP real quick. So what I'm going to do is I'm going to just create a quick job, and we'll just call this, let me call this context, and we'll save that file. and I'm going to save it as US customary. Okay, and I didn't want to create one with a lot of elements here in the layers control, just to help you visualize and see what I'm doing. Okay, so let's look at the terrain. If we look in on the layers network, we have under topography, we have the DTM surface. And if we were to right click on DTM, you'll see that we have that ability to directly create our tin surface from that XYZ, that ASCII grid, or the 12D ASCII file. Very quickly, very easily to do that. We can always just select the DTM builder and do this in a little bit more, I guess, manual way. So in this case, I'm just going to very quickly terrain, and I'm going to select my terrain. We'll import all of those points. So we have XYZ information, okay? And we can very quickly hit create DTM and terrain. I got a directory called terrain, and we'll go ahead and build the digital terrain model from that grid file. This is a little bit slower process than just directly creating it, but I wanted to make sure that you knew how the DTM builder has that ability to import that information, and it gives you a little bit of a step-by-step process as we take that XYZ information and build a grid off that. You'll notice that first row has a what I would call an error in it. It has a Z value of 7, where the rest of this model is up in the 600s. And you'll see that as soon as we get that in the application. You'll see that Z value. I'm just learning this trick here. Press the control. In this location, we have an invalid value. We could have corrected that in the DTM builder, and deleted that or corrected that value properly. Just to show you that we have a terrain, we see this nice orange color, orange fill color. Let's go ahead and turn this and change that into contours in the 10 and 5 step by step. So we can see that we now have a DTM built. We have contours as being displayed. And if you look down just in this area here on the bottom status bar, may be a little difficult to see depending whether you're maximized or not. You'll see as I move my mouse cursor, you'll see that status bar echo that elevation. So this elevation information can help us populate nodes. It can help us build a two-dimensional flood model. It can help us edit pipes. It can help cut cross sections. We can use the cross-section tool here and kind of look and see what that system looks like. And yeah, sure enough, I've got a lot of elevation available. Okay, click off that. All right, my project is in this location. Okay, so the next thing contextually is I want to bring in my background imagery. And I have a file under my webinar, under imagery, that I want to select. I'm going to bring it in, but I want you to realize that we will read the world file for this imagery, and you'll notice that in this case, it really doesn't appear that we have any world information associated with this image. So if we knew what the values are, we could, let me type this in, we could type what the top, the bottom, the left, as well as the right coordinate for this image and import it. And you'll say, whoa, Matt, what just happened? You know, our terrain information is way up here, and our imagery information is all the way down there. And this is, I did this somewhat on purpose just to make you aware that the coordinate systems have to be together. Okay, we're not going to be able to reproject, reproject that information on top of each other all the time. We give you that ability to modify those if we look in the properties and the background images to be able to actually translate that. But if you would work through QGIS, there's an ability to correlate an image, and in the next step, the next demo that I do, this image will be correlated to the terrain information from the design project. But it also gives QGIS gives you that ability to convert both of those terrain as well as images so that you're sticking to a single coordinate system. Okay, and just so that everybody can see, we can actually go back to import land XML, pull in that terrain information, land XML. Here's my existing ground surface. Give it a second to populate, and there's my existing ground surface from the county on this location. You notice again we have elevation information associated with that. Okay, this terrain information is built through those through the DTM builder, with the exception of land XML. Land XML, if we really want to convey or make sure that our triangulation within our tin surface remains the same between, say, our design surface in Bentley or Autodesk, land XML at this point is the only way to make sure that those triangular surface edges remain the same. And we can come in here under DTM, under the grid layer, add a layer. Okay, we can draw that polygon and take a look at that triangulation that arrives with the land XML surface. And you'll see we have a channel in here. Looks like we have a little low spot, and that comes through with the land XML. Okay, had we just taken all of the surveyed shots, added those as XYZ values, we wouldn't preserve some of the break line information that has been added to that surface. Okay. Next, let's talk a little bit about that design information, that design data. We can add CAD file information to XPSTORM, kind of begin to help us with some of that context. Again, it's very, spatial context. They can be a pretty picture. Pretty pictures can actually be both CAD files as well as GIS files. Same concept applies. But we can also use that CAD information to create XP elements. So we can actually create catchments, nodes, and links from polygon information or node information or line information within the CAD drawing, which is a really cool way to kind of preserve some of that information. Maybe you don't have a lot of BIM elements. At that point, it's kind of saves you, I guess, what you would call the digitization of the design. You don't need to remodel something again if it's there. Again, leading you to an efficient design modeling workflow. But the other element is hey, if you are designing with, I guess, what we'd call BIM-like elements, design elements, let's use LandXML. LandXML, obviously, I just demonstrated the surface, but pipes and structures can be imported into LandXML with a lot of that information about the rim and the invert, as well as the pipe diameters already populated. It's saving you time. Okay, that kind of preserves the eye in that design BIM model, if you will. Let me switch back to XP and kind of just show you the steps here. So let me close this model. Let me go ahead and open my design. So as I had indicated before, and I think I glossed over a little bit, I can bring in my existing ground surface via the XML file. Kind of showed you that earlier. But I can also bring in my final design surface. Okay, from the same location. You'll notice that right now the display order here, the first one in this list, is the existing, and that's kind of what we see on top. That's also what we see in our coordinate system down here. Okay, we can just toggle this, but our coordinates are still going to display, and we can leverage that information there. But let me just go ahead and delete that first one. So get under the idea or the concept of trying to get it so that you have a single LandXML surface. Even though we can load models here, it's the top one in that list that is used when we use these tools here, generate ground elevation information, or when we pull 2D flood polygons to create that grid. So we kind of just want to make sure that we have that information, in one place, in one element. So again, massage that data to make your flood modeling easier. And I want to grab my aerial photo, and in this case, here's my design surface aerial photo. It's the same image, the one, but this one actually does have the world file associated with it already. So here we have that. I can, again, very easily change my display of my surface from the nice color gradient to contour information. And I can, let's go ahead and zoom in here and just take a look at the model. Okay, looks like we have some lots and things like that, plus a pond. We have a stream that comes through here, some design elements down here at the bottom. Okay, just to kind of leave the surface on, but I'm going to turn the background off. So what if we have CAD data? We want to use that, again, provide not only us, but maybe provide us some ability to do some design work and be involved in that process. We can actually grab the overall site plan here as a CAD file, and it zooms us to the extent. I can bring that back in, take a look at what we have. And just like most CAD information, we have that ability to turn off some information that maybe we don't need, lot numbers, roads. We can see where the lots are being placed. We can see the contours or the parcels, from the CAD file. Great backdrop information. Well, Matt, you said we can actually create elements from CAD data. So I'll go ahead and grab my catchments, and I'm going to go ahead and turn the overall site plan off, actually turn the surfaces off, and zoom in here. So here we have polygons in our CAD file that represent our catchments. Okay. We can actually select these and import by right-clicking. And let me select none. And I know these are all on this PR drainage area layer, but there are, a bunch of layers in this drawing. And I can actually then create them as catchments. Okay. You notice that we also do nodes and links, and we'll get to that in a second. But we can pull catchments, and I can create all 41 of these catchments with just a handful of clicks. It's pretty quick, pretty powerful tool. So we have all of this information. Boom, yay. Let's go ahead, and I'm just going to turn all of that off real quick just to help declutter our desktops and make it easier to come across on GoToWebinar. It's going to go ahead and load the next CAD file. So in this case, I have storm sewer. And if I were to zoom in here and take a look at some of the storm sewer, we just have line works, and it looks like blocks and text. Okay, great. What is that going to help us with? Well, we can actually do very similar elements. We can look at, all the storm manholes. And we can go, and these are all nodes, and I will grab all the circles in any of the boxes. Now, in this case, nothing created there. Did I grab the right? Oh, that's right. I forgot to show object count, and I should have realized that at that point, whoever did this put those all on layer 0. So we do have that ability to see what those elements are. In this case, we have 18 polygons on, no points, 678 lines, and 118 polygons on that. And we can come in here and create our nodes. But these nodes will, I'm just going to grab the circles. These nodes will be what I would call dumb nodes. It's a shortcut for digitization, if you will. It does not grab any of the information, not that this CAD file had any of it, but we would have to use tools like generate ground elevations from tin. Another reason why to bring your tin in is we can then push all of those nodes, give them rim elevations, and we can begin to add that vertical, if you will, through other means necessary. Let's go ahead. I'm going to delete those. In this case, what if we have more design information, better design information? Maybe we've already created a pipe network in Civil 3D or GeoPack. Well, Civil 3D, can export that pipe network to Land XML. And we can leverage Land XML and that BIM model here and actually generate somewhat intelligent elements. Zoom previous. Let me turn off some labels here. And we can investigate what we have. Select all those. I want to take a look at this end profile. And we can realize that, wait a minute, as with really any of this data information, we need to use a keen eye, if you will, to notice the fact that even though I'm getting pipes with the correct diameter, and it looks like I've got rims and I've got some inverts, occasionally there are some things that these formats don't handle well. In this case, our outfall has a 0 value in it. That will require us to manipulate. Okay. And I know that just because of the design information, design surface. Let's see here, downstream. I can make that edit very quickly and very easily. Okay. So always check your data, whether that is CAD data, whether that is Land XML data, whether that's terrain information. Just make sure that you've got what you want, to make your design even better, if you will. Next, that third method, the simulation data. We can look at different simulation tools that were developed kind of different for different purposes. HECRAS was, it's a river analysis system. It does really good elements for river links, and it defines cross sections pretty well, helps you do bridges and things like that. That it has a purpose, but in many cases in urban flooding, HECRAS probably isn't the best tool to use. You can get situations where urban flooding isn't always associated with just stream overbank flooding. I think the state of Illinois put out a study where most of the flooding and flood damage that it does occur isn't associated with riverine systems at all. Yet most of the flood models for those locations in the floodplain that regulates the development within those areas are all modeled with HECRAS. That may be changing, but hey, how do we preserve this information? How do we really not orphan this data? How do we merge this into our XP Solutions model and utilize that? And that goes for elements just like EPA SWIM. Again, they all have their strengths and weaknesses. This is, you can probably run cross-sectional information in EPA SWIM. Visually, if you were to hand that to your neighbor who's flooding, they're not going to understand it. So how do you communicate that? Let's bring all of that information into XP Solutions and leverage that data. We have that ability to not only do surface flooding in the one-dimensional element, but we can actually build that two-dimensional surface flooding stream, overbank it with one-dimensional elements, but two-dimensional surface flooding, inlet surcharging, put it all together so we get a better picture of that broad flood context. Okay. The model that I'm kind of demoing is kind of a minor model, but you can do a lot more with that information there. You can do a lot more with an XPSTORM than what I'm showing. This is very much a beginner type element. One of the other things I want to also stress is some of the global data that we have available and we can share and merge. XPSTORM as well as XPSWIM both share a similar mechanism called global data, and that global data will help kind of save you time, make you efficient. You can share elements out into a template, or you can share that out to an XPX format that can be reused, or you can merge that information. Merging isn't just for taking nodes and links and bringing it into your model. You can bring in job specifications, you can bring in other global data to your model. Just want you to be aware of those different methods and go from there. So, looking at the time, the only thing I'm going to show you is some of that GRAS information, and we'll talk a little bit about global data as well. All right, let me switch back to XP 2017. I'm going to go ahead and close this model, and I want to open, I have a simulation model that I have started. Obviously, my train is in there. My aerial photo is in here. Let me go ahead and turn some of these things off just to, we'll leave that on just to help provide a little bit more context or a little bit better context. But as we look at some of the simulation information, we can look at elements, switch my mode to run off, look at some of the simulation information that is available here. I've pulled all of that phase one BIM model, summarize that into a single node. But one of the things I wanted to bring you to your attention is on the global data. In this case, I have the NRCS MSE4 and MSE3 storms available within this model. And this is something that can be pasted. If I look at Excel, there is a spreadsheet that is provided by NRCS. In this case, this is in the Midwest, that has the times and values for this distribution. Okay, that can be just then copied and pasted into our global data. Okay, and that global data can be reused, in other models as well. Okay, let me close all of this, and that can be, brought in and that run combined. Okay, in this case, we had in the design condition, we had a HEC-RAS model. So if we look to File and go to Import, we can import the HEC-RAS. And by importing HEC-RAS, we can come in here in the simulations, and we can select that geometry file. And I want to make sure that everybody knows with HEC-RAS models, you can have multiple geometry files within your HEC-RAS simulation. So you got to make sure that you find the one that you've modeled in HEC-RAS to be able to import this. In this case, my geometry file, I only have one of them here. And so if you have a simulation that has multiple, just make sure that you look for the right G0 with the number sign that you want to import. In that case, we can import this, we can bring in that entire network, bring in just cross sections depending on your need. I'm going to get the river, and I'm going to get all of these cross-sectional shapes. And if I turn off my surface, you can kind of see, hey, I now have a HEC-RAS model in here, and I can look at my river links, and I can go to edit the data. And a river link is very similar to regular link, which had a natural cross-section. This always will have a natural cross-section. And that natural cross-section is this shape. And if we look at the edit of this shape, okay, you'll see we have the cross-sectional information associated with that HEC-RAS model. We have our left bank and our right bank stations already shown here. We also have left and right overbank meanings values for that, as well as the cross-sectional distance between those. So, we now have technically not really orphaned that data, but we've been able to bring that information in so we can then actually do our duplicate effective model, and in our design condition, look at limiting this to, say, only within this small channel area, where we have flow coming down here. We have that ability to look at 1D in the channel and look at our assumptions about how this floods into the overbank. Okay, so we can look at that and bring that information, merging these two models, to kind of help get us a better context. There's a lot of hydraulic fun that's going on in this model, and we don't want to always have to recreate the wheel. Okay, we can always look at elements like land use, and I can always bring in GIS data for areas that represent, no, wrong one, for my road, and we have, there's our road polygon. So we can begin to convert some of that CAD data, some of that design data, bring that in to help begin to populate our flooding model, for a two-dimensional flood analysis surface. Okay. And I'll kind of show you the results of that here in a second. But on reuse, how do you want to reuse that global? How do you get rid of, not really get rid of, how do you share your reusable data? So for example, we have that MSE rainfall distribution in our global data. How do we get that out? Well, we do that through the XPX format. And in this format, we kind of just, turn off nodes, we'll turn off links, we can turn off job control, and then just select the selection button, and that'll allow us to limit our global data so we can find our rainfall, move it over, and click OK to export that to an XPX format. So that's kind of how you begin to reuse some of that information to help, I guess, use it later. I want to thank you for joining today's XP webinar, XP Solutions webinar on data preparation and flood modeling. My email address is there. I gladly take any comments or concerns or questions or ideas for other webinars.